So in this example, we consider a online computer shop, and they did a survey last year asking about like their customers plan to purchase a new computer, and then 1 year later they did a survey again to see if they actually bought a computer or not. So pretty interesting. So and what we have to do is we have to check if plan to purchase a new computer is statistically independent of actually purchase the computer or not. And two questions. This is one, you have to find it out. And also the plan is related independent of purchasing parts instead of a whole computer. Okay, so when we say A and event A and B are statistically independent, then there are several ways to show this, whether it is independent or not. Method 1, you calculate probability of A and probability of B, and calculate probability A intersection B, A cap B. So calculate these probabilities separately, and if you multiply the first two probabilities, and if the product equals the intersection probability, then they are independent. Okay, the second method is you may calculate unconditional probability of A and calculate probability A when B happened. And finally, probability A when B does not happen. So by changing the condition, we are comparing probability of A in three different cases. You just need to actually check two of them. If any two of them are equal, this equality or this equality or this equality, doesn't matter. When they are equal, then they are independent. Right? Actually, the third method, basically the same thing, is flipping the role of A and B. Our idea is the same. By changing the condition defined by A, you compare the probability of B under three different conditions. I will show each of all the three cases and show you how we can do it. So I will think about the first question, plan and computer. I will denote them like this. So I am going to calculate probability of plan and probability of buying a computer, and probability of planned to buy a computer and actually bought a computer. Okay? To calculate each of them. So first I'll calculate probability of plan. So unconditional probability of planning to purchase a computer is 60 plus 100 plus 240 plus 90 plus 150 plus 360. Out of this many respondents, out of that many respondents, how many planned? This much, right? 60 plus 100 plus 240 planned to purchase a computer. That is, denominator is 1000. I believe it should be 1000. And then out of them, 400 planned to purchase a computer. So that is 40%. Or, okay, let me write it as 0.4 for the algebra later. And then now let's calculate unconditional probability of the customers who purchased the computer. This set, okay? That is out of the same 1000 respondents, 60 plus 90 purchased the computer. That is 150 out of 1000, which is 15%, 0.15. Finally, I will calculate the probability of both happened. right? Both happen, right? Plan to purchase and actually purchase the computer. So that's only that area, 60 out of 1000. That is 0.06. Okay, what you have to check here is multiply the first two numbers here, multiplication, and compare that to the last one. The answer is you can find they are equal. So they are independent. So these two, planning has nothing to do with actually purchasing a computer, right? In this example, in this numerical example, that's what we get. Okay, this was the first method. Let me try another method. So I am going to calculate probability of actually purchasing a computer, and I will also calculate probability of purchasing computer among those who planned. And also, you may just choose any two of these. Among those who did not plan to purchase a computer, how many of them actually purchased the computer, right? So we'll calculate unconditional probability. We did it already. So 150 out of 1000, it is 0.15, right? We are calculating this area. Let me erase this too. Okay. And now, given that a person, a customer, planned to purchase a computer this year, how many actually purchased the computer? So the condition is planned to purchase computer. So this is the first row is what we are interested in. Out of that many, only 60 purchased the computer. That is, it is 60 divided by 400. If you calculate that, you can find 0.15. So already actually you can find the answer. If those two are the same, then automatically the other will be the same. Let's check it. If you did not plan to buy a computer, so the second row now, condition is the second row. So 90 plus 150 plus. Out of this many, only 90 people bought a computer. So that is 600. Out of 600, 90 bought a computer. If you calculate this number, you will also see it is 15%. That means all these probabilities are the same. So the probability of buying a computer is independent of whether you planned it or not. In that sense, they are independent. Okay? So either way, I showed you the same result using two different methods. So it does not matter what you use. I'm just showing you different method. Finally, you may change the the role of two events. So you may calculate plan as a main event of the probability of those who planned out of the who bought a computer, probability of you planned out of those who did not buy a computer. Okay, so we know the result. The result should be equal, but let me just calculate it. In this case, especially, I wanted to show you how to calculate this guy. So you did not buy a computer this year. Then actually among them, how many of them actually planned to buy but couldn't? So think about those who did not buy a computer. So this is those who bought a computer this year. Then its complement is this much. It is not just one column. It contains 4 outcomes. So the last probability can be written as this. Out of this, how many have actually planned this many? So 100 plus 240. So if you calculate that, denominator is 850 and numerator is this much. So this is the probability. And if you continue to calculate the probability for, let's say, plan, that means out of the 1,000, all the people, how many planned? This many have planned. So 60 plus 100 plus 240, that is 400 out of 1,000. Oh, something, I think I made a mistake. So I'm not sure. So it's right. So 40%, they are the same. So you can find these two events are independent. You may apply the same method with changing this event. You can calculate the independence relationship by yourself. If the equality fails, then they are not independent.